Hello there. I'm going to be taking you through the build of the B2-EMO Pro head mechanism designed by David Ferreria, as seen on Michael McMaster's B2. Dave has very kindly put together this kit for me that I can now build my own head mechanism and take you all through it. So from Dave, there's a number of McMaster car parts. There's these cut plates from Send Cut Send, and a lot of other things. There will eventually be a bill of materials released on Michael Baddeley's website, Facebook page. So the first thing to do is there is some preparatory work. So these Send Cut Send files, it's necessary to tap a number of holes. So on this plate we have M2.5, M3 and M4 holes, and we also need to make some countersinks for M4 screws so that the heads sit totally flat with this plate. The same with this plate, we have M4 countersinks. Okay, having spoken to Dave and checking the CAD files, there are a couple of modifications required on this bottom plate. Firstly, the M4 countersinks on these 4 holes, but there are also 3 M3 countersinks around the outside to mean that all the screws holding this in are flush fitting. Also, this hole in the centre needs opened out to about 14.5, 15 millimeters in diameter, so that the tube with the bearings in it will pass through. So that's the first modification required. And then on this larger plate, we have some M4 holes that need tapped, M3 holes that need tapped, and then M3 countersinks over here. As well as that, there are 3D printed parts. So this is a plate which there's a number of M3 heat sets in there. These are McMaster car heat sets, not the standard ones you can get off AliExpress. And then there's M4 here for your slip ring in the center, and there's 4 more M3 heat sets on the bottom. M3 heat sets here, and then we have a small Lazy Susan bearing, which is 5.5 inch diameter. This needs to be match drilled along with these 2 3D printed parts. There's the gear mechanism, fits very snugly over, makes it very easy to match drill. And then this center spacer, you need to match drill that as well. All of those holes need to be drilled at 2.5 millimeters and then tapped out to M3. Okay, so I will actually start the assembly now. Okay, so first part of the assembly is we have a Go Builder aluminium tube here. And Go Builder linear bearings. And these need to be pressed into the tube, which I'm going to actually have to take off and press fit these in my workshop. So I will come back to these. Turned with this 14mm tube, I've press fitted the bearings into each end. They're 6mm internal diameter linear bearings. I froze the bearings and heated the tube up on a printer bed just to ease them in that first bit, and then press fitted them in. So you need to make sure that you press fit them very straight in there. A further modification is that this aluminium tube, the 14mm tube, which is supplied as 100mm length, needs to cut down to 70mm with a tube cutter. The bearings are then press fitted into it, and because each of these linear bearings is 35mm long, they will butt up against each other in the centre there. Once that's done, we take the bottom plate with the hub attached, loosely attached with these screws, which will still allow for the clamp to close, and then we place this through. The shaft, the tube should protrude through the base by about 7mm. So if we tighten that up, and then snug up these screws, cross pattern. So this is now ready for mounting in the bottom of the assembly. Okay. First thing I'm going to do is I will fit this plate, and I noticed while I was doing the linear bearings that I'd missed 4 countersinks for M3 screws on the corners as well. So this one fits in the bottom here. You'll see there's 2 holes here for wires which have to be aligned, and we'll use some M3 by 6 screws. So those screws, I've put them in just gently to begin with, and then I will tighten them in a cross pattern. Which just makes sure there's no uneven distribution of stresses or anything. So that's that. Next thing is we take one of these Go Builder clamping hubs and fit it to the 14mm tube. Nice and straight. And you want this to be nice and tight. Okay. It will fit down in the base there. Hopefully you can see the orientation for it. And to mount this, we'll use some M4 by 5mm button. Oh no, sorry, my mistake. M4 by 12 countersunk is what I meant to say. Okay, so I've just noticed another slight mistake I've made, nothing critical. I've got this gear attached to the bearing, and I said that both of these sets should, these holes should have been tapped to M3. The outer holes, match drilled to the gear, should have actually been a clearance rather than a tapped hole. So I will go and disassemble this and drill clearance holes for all of those now. Okay, so previously I had said that this bearing was match drilled for the gear, and it was also match drilled for the ring around here, and then M3 tapped. What I should have said was it was M3 tapped on the inside ring and then M3 clearance on the outside, because what we're going to do is we're going to fit this and screw it down to this plate using M3 by 16 screws. Okay. Now what will happen is that there's this plate and this gear are locked together with the outer race of the bearing, and then the inner race of the bearing, it is attached to the upper assembly, which has the motor on it. So the motor has to be powered through a slip ring, and it will rotate the whole top section while this area is fixed. And I could have probably done with running a 3.2mm through the plastic of this as well. It's just catching on the screws very slightly. And this just screws into the heat sets. And 8 of them in total. Again, this plastic is just catching on some of the screws slightly. It doesn't want to push through, so I'll need to screw it through. Once again, we're not going to tighten any screws up until we have all 8 of them in, and then we will tighten them in a cross pattern to make sure we don't distort the bearing at all. Struggling to get this last screw aligned with the heat set. Just loosen everything off slightly in the hope that it will go in. There we go. As I say, tighten in a cross pattern. Okay, that's very solidly mounted, and the centre bearing is still free to move. Next thing to fit is the slip ring. So you'll get the part number off the bill of materials. Now we need to turn these around so that they fit on here, and then I clamp down with the M4x5. Excuse me, clamp down with the M4x5 button head screws. It's a bit tricky with all these wires hanging out everywhere. Means you can't have a flat surface to set it down on. Again, try and balance it while I get this first screw in. Slightly magnetic screwdriver helps a bit as well. I think most people that are doing this modification will have built the rest of the B2 already, and seen how responsive a droid it is. It is really good. Really good design by Michael Baddeley. This is the second iteration. The first one was by Michael Baddeley, allocating the New Zealand, Australia, sorry, my mistake, and Tim out in Florida, or Florida now anyway. So they did a very, very good job on the version 1, but this is obviously for the version 2 now, which is larger overall, but also uses larger servos, etc. for all its movement. The macadam wheels and the macadam wheels and motors are still the same as previously, but yeah, the servos for the body lift and the foot lifts, they are all increased in size. I think the original bill of material that Michael released has 60 kilo servos on, which still run at 7.4 volts. Michael McMaster has fitted 160 kilo servos, so they run at 24 volts, or the battery voltage I think is 22.2 volts or something like that, but at much reduced current. So that's what Michael McMaster's is running at the moment. Okay, next we will slip this ring over here. So these definitely are clearance holes on the plastic, but then they're tapped into the bearing. And what they're doing is they are going to hold this plate with a clearance. Struggle to find the holes now. That's about it. Yep. And then this is held down by M3 by 16 screws again. And I've just dropped screws everywhere. Just try this again. And these okay, you can see these going into the countersunk holes through the plastic bracket. So the countersunk holes mean that these are sub-flush. They're not going to catch on anything. And we've got about 8mm sticking through the other side. Feed all these wires up again. We have to try and get these threaded into the bearing itself. I'm just pressing on the center rather than the outside of the plate. I'm going to try and seat this down towards the bearing. There we go. It's going quite a way. Again, don't tighten them until you've got all of them in. Possibly needed to chase the thread out on that one a bit. There we go, it's in now. So once again, tightening in a star pattern. Okay. There we go, so that rotates quite nicely. Okay, I'll pause just there for a few seconds so that I can clear off all of this, these markings, and I will be back in a second. So continuing up the structure, we will now fit this 3D printed part, which will lock the rotating part of the slip ring using this metal collar which comes with the part, and it will lock it to this top plate. So there's holes in the side of this unit, so just align the hole as best as possible. That seems to be about right. Yep, that's caught. And you've got these two clearance holes at the back which align with these larger holes at the long leg here. So this just goes in, and you can feel it clamping down on the plastic, and then just run this screw in enough to grab on the plastic of the slip ring, and then you can see that these will rotate together. This is held down with a number of M3x6 button heads. The Go Builder motor driver will be fitted at the end here, but I'll not do that just at the moment. We will get this snug down first, and because it's 3D printed part, you may need to push and bend it slightly to get it into position. It can warp slightly on the print bed, I'm sure we all know that. Okay, so we've got 4 screws on the side, 4 on the long side, and then 2 on the shorter side. And the reason for only being 2 on the shorter side is because we're going to be mounting something else on these screw holes. Again, I'm not clamping down until I've got all the screws in. Obviously 3D print is a bit more flexible and forgiving than metal to metal holes, but you still don't want to put too much distortion in there if you can help it. And I'm trying not to drop screws down in the middle here as well, because that's going to be painful to get them back out. I'll end up having to tip everything upside down to get the screws out. Okay, and now I can start tightening these down. Obviously the bearing's working, so you've got to hold on to things. And over here we're going to have a mount for the Castle CC voltage regulator, BEC, whatever you want to call it. So it's just 2 M3x6 screws held in here. In here we'll be fitting 2 3-way Wago connectors, and then there will be a lid going on the top of that for the Castle CC to go in there and wire in underneath, but we'll not do that at the moment. Next up, there are 3 very beautifully machined servo mounts. These are machined and anodized, I believe, by PCB Way, and yeah, they are very nice indeed. They mount on these 3-hole positions, 3 spaces around the plate, and again it is with M3x6 screws, button head screws. Not quite as easy to get them in because they are hidden down in amongst the machining. I'll just fit these loosely to begin with. Let me see if this locks on a lot better on this driver, so just snug those down. Two and 3. And the last one over here. Okay, so that's those mounts. And the last thing I'm going to do before I stop at this stage is I'm going to fit the motor. Okay, so it took me a second to find the motor. Here it is. It's a Polarlu 37D 19:1, 24 volts. So it means no power conversion is required. And we're going to attach it to this plate here. again, it's 6 M3 by 6 button head screws. Sorry, moving it away from the camera there. There we go. Just struggling to find the alignment myself. Now this is going to be mounted on this metal plate using hex, male to female, M4 connector, which I will connect in a second once I've got these in. And obviously there's a gear that needs to go on the shaft, and we're using a 6mm sonic hub to attach the gear. They're very good at making sure there's no slippage, zero slippage. Okay, almost there. There's my computer just sleeping. Right, and then tighten these all in a star pattern again. Okay, so this is going to mount just here, and the gear is obviously going to engage with this lower gear. So we have 4 of these, and I believe they're going to need cut down. Because they stick through quite a bit, and if I don't cut them down, they are going to bind with this gear here. So I'll show you. You can see that these stick through quite a lot, and they would bind on this gear, which is static. So I'm going to have to cut these to the thickness of the plate. So I will be back shortly. Okay, I'm back once again. So now I've reduced the length from approximately 9mm on the original parts down to roughly 3.5mm. So should still have full penetration of the plate that they're going through, but will no longer bind with the bearing. And yep, I can see that those definitely have not bound. These appear to be aluminium, and they've got a tapered shoulder on the thread, so be very careful when you are tightening them that you don't tighten them too much and therefore break the thread off the hex. I'm just struggling to get that last one threaded. Yes, it's a 6mm spanner that you need to tighten those, but not very much beyond, just finger tight. Okay, so on the bottom we're going to fit the gear, and we're going to fit the sonic hub, which is a 6mm sonic hub. It's the round bore rather than the D bore. And these side screws are the ones that are used to tighten the sonic hub onto the shaft, just in case people, well, if you build B2, you've already used them, so that's not an issue. This is going to be mounted onto the gear using M4x14 screws. 4 of them. Yep. Just finding the correct Allen key there. So I'm going to put the sonic hub onto the motor shaft. I'm not going to tighten it at this point because I'm going to have to align this gear with this gear just to make sure that they're not binding in any way. But I'll just tighten the sonic hub enough to hold it onto the shaft and no more. Okay, so the sonic hub is on there. Sorry, I keep forgetting to have it under the camera. Slide it on here. As I say, it's circle rather than the D-type, so it will fit any orientation and just slide around. But that's not an issue once you actually snug it down. Okay, and then this is going to mount on here. So, yeah, not quite yet. It's not allowing the gears to align. I've now made that loose so that I can slide it into position. And we're going to mount this motor plate with 4 M4x6 screws. Just try and align these gears roughly. There we go. And you can see the gears just slipped there. Until those gears engage properly, you can't get this other screw in. There we go, got it. So yeah, that's, the gear is meshed nicely. There's the fourth one gone, there we go. Okay, and then tighten this down. Okay, and now that I have these 2 gears meshed nicely, I can snug up the sonic hub. Okay, so that's where we are. We've got the mounts for the servos, we've got a mount for the Castle CC, we've got a mount for the Go Builder motor driver, got the motor mounted, and we've got a slip ring in the centre allowing cables to turn freely. And that's where I'm going to leave this video for this evening. And I'll pick up with mounting the extra hardware there, and then probably working on the top down and then meet in the middle. Okay, thank you.